Hi everyone. We're going to look at how to resolve vectors in order to find a resultant vector. You got a couple of vectors, put them together, resolve them, and then you find a single one that is equivalent to the other vectors you've resolved. So it's resolving to find a resultant vector. And we are going to look at a problem that says a vector of magnitude 4 acts at an angle of 60 degrees below the positive horizontal direction, and a second vector of magnitude 8 acts at an angle of 70 degrees above the positive horizontal direction. Find the magnitude and direction of the resultant vector. So let's go. If we sketch something like this, and we say this is our positive from here, this origin here, this is our positive direction going up, we call it V, Y, and this is our positive horizontal direction going towards the right, we call it V, X. So now, let's see what the problem says. It says this vector here has a magnitude 4 and acts at an angle of 60 degrees below the positive horizontal direction. So the vector here acts below the positive horizontal direction, the angle of 60 degrees below 60 degrees, and it has magnitude 4. So it's going that side. And I have a second vector of magnitude 8 and acts at an angle of 70 degrees above the horizontal, positive horizontal direction. So it acts at an angle of 70 degrees above the positive horizontal direction. So that's magnitude 8. Now find the magnitude and direction of the resultant vector. So let's resolve these two vectors. But one thing you can notice straight away is that one is going up, one is pointing down. So if we are going to resolve these two vectors along the vertical axis, one is going to be positive, one is going to be negative, because they are going in different directions, or opposite directions to say. But on the horizontal axis, you can see they are both going towards the right. So they will have the same sign. So now let's start resolving. We resolve along the horizontal, the positive horizontal axis, which we have already said Vx. So Vx, now let's start with this one. If you are resolving this one along the horizontal axis, it's going to give you the cosine. So Vx is going to be 8 the cosine of 70. You resolve this, it's positive as well. This is going to be 4 the cosine of 60 degrees. And what we call for the horizontal. For the vertical side, Vy, now, what do you get? You're resolving along the vertical axis. So you're going to get 8, the sine of 70, this is going down. You want to resolve it positively here. So it's going to be minus for the sine of 60 degrees. Sorry, 70. Let's explain this so that it can benefit other people. How have we resolved this? Let's see. Now you have this one here. You have this force. You have this force here. This is Vx. Our Vx is here. You have 70 degrees here. This one is your vector with magnitude 8. You have this right angle triangle. You want to find Vx. You don't know what Vx is. I'm looking at this top vector. You want to find Vx. You don't know what Vx is. You have this right angle triangle. But from your trigonometric identities, you know that you are looking for the adjacent side of this angle here. You got the hypotenuse side and you want to find the adjacent, and you have an angle. So what trig function should you use? You use the cosine, because you have this. You know this paradigm. So, toi. The sine is opposite over hypotenuse. The cosine of an angle is adjacent over hypotenuse, and the tangent of an angle is opposite over adjacent. Sine of theta, you are looking for the angle theta, the sine of it, you have opposite divided by hypotenuse. If you are looking now for the cosine of that theta, you have adjacent A all over hypotenuse. If you are looking for the tangent angle, you have opposite all over adjacent. These are trig functions, trigonometric identities. So now, what do we have here? You have the hypotenuse, you have the angle. Let me say you want the adjacent. So hypotenuse, adjacent, what connects them? Adjacent, hypotenuse is just the cosine that connects adjacent and hypotenuse. It's the cosine. So this is our candidate. Now, you know, now that the cosine of 70 is equals to the adjacent, which is Vx in that case, all over the hypotenuse, which is 8. So now you will have 8, the cosine of 70 equals Vx. Because we want Vx, we are resolving along the positive x direction. So we want Vx. So this is how we got them here. Vx, 8 cos 70. You do the same thing for this other one. When it comes again to the vertical axis, you do the same thing. Just apply these rules, then you get them. And you get the signs correct. So I hope this helps to explain what we have just done here. Now, let us find real values now. 8 cos theta, 8 cos 70, I'm using my calculator. The cosine of 70 times 8 2 point, breaking it down, 2.73616. So let me just do everything at one go, that's better. So we have 8 cosine of 70 plus 4 cosine of 60. You get 4.73616. Let's stop there. And now you have 8 times the cosine of the sine of 70, sorry. 8 times the sine of 70 minus this time 4 times the sine of, this will be 60. Yes, 60, sorry. 60, sine of 60. Four point 0 5 3 4. 3. Let's stop there. Okay. I hope our calculations are correct. But the method is correct anyway. So now we are asked, we have these answers here. If now you want to convert this to the unit vector, this is going to be I, this is going to be J. Write it in a vector form. It's going to be R equals 4.373616I plus 4.05343J. If you want to find the resultant vector here, want to find the magnitude of this is now the resultant vector. So what do? Magnitude, you have the square root of the sum of the squares of these two numbers. You need to square this, 4.73616, square it, plus 4.05343, square it. To find the magnitude. Again, let's do that. I'm gonna do the square roots of 4.7 4.73616 square plus 4.05343 squared. What if I press wrong button? The square root of 4.05343 616 squared plus 4.05343 squared. Gets something like 6.2338. Let's say this is approximately 6.2, but since here we are given just single digits, we can just assume to be 6, right? So what we now have here, this is the magnitude. Now we need to find the angle or the direction of the resultant force. This is the magnitude of the resultant force. To find the direction, we have, say, this angle. You have the x component or the horizontal component, which is 4.73616, and you have the the vertical component, which is 4.05343. Your angle is here, and this is your force. So you want to find the direction. You want to find the direction of your vector. So what do you need here? You have the opposites and you have the adjacent. What do you use from the trigonometric identities we mentioned earlier before? You use the tangent, because tangent gives you opposite and adjacent. So if you say now the tangent of theta is equals to the opposite, which is 4.05343, all over the adjacent, which is 4.73616. Want theta, not tan theta. So the theta is equals to the arc tangents of whatever you get from this fraction. Let's do the fraction and see what we get. We are dividing 4.05343 divided by 4.73616, getting 0.8558. Let's stop there. So now we need the arctan of this, of 8.558. So arctangent, why is arctangent here? I need this shift button, arctan 0.8558. Calculate. I don't know, I'm getting 40 degrees, 40.55 degrees. So since we are doing this one at 1 degree, so I assume it's like 41 degrees. So that's what we got. The direction of the resultant force is 41 degrees, and the magnitude of the resultant force is 6. I hope this helps. Thank you for watching.